So we're sort of, it's more an update than a tutorial. We're sort of getting to the point where it needs to be more a discussion rather than we try to formulate it into some form of teaching system. I'm hoping that by now you've managed to follow some of the tutorials that I've done, and so we can start discussing things with a view to building on that understanding without it really being attempted to achieve anything within the tutorial. One of the things I talked about was going over to building a whole new brain, and I've actually gone and done that. Not as far forward as I'd like to be, but because time, you never have as much time as you'd like. We all have to make a living, and even in these COVID times, we need to be able to make sure that everybody else at the factory is getting the things that they need. And I've had to do a lot of programming to keep things going. So I have managed to build a brain. Now it's almost a month ago since I built these brains, and I kept promising myself I'll do an update, and I put the site together on the put the channel together on YouTube, and to get a chance. So let's start by actually having a look at this is the commercial version of the brain that I've designed. And I can only sort of generally discuss this because unfortunately it is going to be a commercial solution, and so I can't really give you a circuit for it or anything like that, but what I can do is do a general discussion on the way that the whole thing's put together. So what we've got in the middle there, we've got the little teensy. I say little, it's the Teensy 4.1, which is the biggest one that they do, which is the reason I went for it. And surrounding it, I've got some voltage converters so that I get past the problem of the Teensy being a 3.5 volt component. Now, this board is already obsolete, and I'll tell you why. One of the things I discovered, I've also made a smaller board, and one of the things I discovered is these voltage shifters can't deal with analog properly, and so this one here is going to have to disappear because those analog chips there, or analog pins there, are just not responding to it, and the next version will literally not have that there. So rather than bother you with this anymore, I'll take this one out of the way, and we'll actually bring in the one that I've built with a view to this being, go back to the wide shot, with this being where we're going next with the robotics. I've literally put it on a very old platform. Let's take you over to the camera so you can see this. Now then, this is a really old platform, and more than anything else, I wanted to just use it to make life easier. Literally, what I've done is built. I'll go plug that in. I've literally built it into replaced the old electronics that was on there, which was actually a parallax processor, which shows how long I've been messing about with these things. I've got myself tied up with the microphone, naturally. I'm not going to be able to win easily with this. Oh dear. Let's just throw that under the microphone, and then when I get solved one problem, we then get the next one, which is now the USB is under the microphone. Sorry about this. Here we go. Nobody said it was going to be easy. So we'll now connect back in the USB. So let's see what the rostrum camera sees. Yeah. So you can see now on this is the I suppose it's non-commercial one. The reason I say that is if you notice the commercial one had RJ45s around the edge, and that's because all the systems I've designed that we use on the you can't even see me in Miles Bay. Let's see if we can move that camera as well, make life easy, so we can at least preparation is king, and I haven't And so consequently, it's not right. So do we start again, or do we keep broadcasting? Let's keep broadcasting. Nobody said it was going to be professional. Oh, that'll do as ish. So, the difference between the commercial brain and the robotics brain is literally down to, if we go into the rostrum camera, I've gone over to what I talked about in the previous systems of how the SaneSmart did their breakout boards, where what you've got is you've got each pin, output pin, has 3 pins on it. The inner one is the signal, and then you've got 5 volts in the middle and the 0 volts on the outside, so that when I actually want to literally go, like if I go straight into that little infrared there, I've got both voltage negative and the signal on one connector. So what I've done is I've crimped these connectors up in 3s, so that we've literally got the whole thing being able to power sensor after sensor after sensor. And I'll come to the slightly wider shot. What you can see there, and if we zoom in a little bit, what you can see there is that not go too tight. Just want to show. So what I've got is literally a whole bank of sensors. Because this is a round robot, and I'm using the omnidirectional wheels in a 3-way format, what we've got is literally 3 sets of sensors on each of the corners. The first one, which is the one that's in the middle, and again I've used blue tack, just hold them on. You know, we're playing here, we're experimenting. Let's allow us to change his mind every 2 minutes, and blue tack is just a useful thing for that. So I've decided that that's forward. I've actually written on what the numbers for the actual motor controllers, because underneath, if we actually go, can I get to that wide shot? I go to the arena cam, as was. Underneath there is actually 2 L298 motor controllers, and they are connected into the first bank of 6. Because there's only 3 motors, you only need 6, although there is 2 spare. The first bank, those are the 2 spare there that are just literally hanging loose. The first bank of connectors. So if you actually look at that, all I've done, which is something that you could easily do in a breadboard, I've literally plonked my teens in the middle, and then the pins are going straight into these voltage shifters with the 3.5 volts on the inside and the 5 volts on the outside, and I've literally gone all the way down that side, and then I did go all the way up this side. You can see this one has already got that 5th chip removed. I did actually create some using transistors, just to actually see how easy it is to do a voltage shift using the actual circuit, which is available on the net. I'll do a link to it at some stage, where you've just literally got one of these transistors on each of these. So the bottom 2 inputs, because there was 2 spare, are actually running through the transistors. Now then, when I do the next iteration, that chip's going to move down 2 pins. Those transistors are going to disappear, and that will have, instead of 8 pins on it, it'll actually have 10, because there are actually 10 analog inputs on this on the teens there. So let's have a look at where we are with the software. So what I've done with the software is literally create myself nothing more than something that is looking at all these sensors. So all these sensors are being pulled. Now then, normally with an Arduino, you would consider actually only looking in the direction you're going at, but because this thing runs so quickly, it's literally running at 600 megahertz. Because it is running so quickly, what I've done is I've taken advantage of the machine's speed, and just said, I'll look at all the sensors. So as I said, this is the update. So the first thing I've done is I've brought in the Sharp library, which you see there. Then I've defined 3 Sharp sensors using the Sharp library, and actually using the sensor numbers, which there are 2 types of sensors that the Sharp do. They do the A2 and the A4, and if you just put the number in there, the system will work with them. I've then gone and defined a couple of constants, which in reality, that's now redundant, so I could get rid of that, because I've then redefined all those constants 6 times, which these constants, so let me explain, I'm going a bit too quick. The Sharp, those are defined on analog pins, which is why it's A9, A8, A7, which those, if you actually go over to the rostrum cam, you can actually see that those 3 come in there. I've then shunted across where the chip was, and that goes into those 3 pins there. So literally, you've got A9, A8, and A7 are the 3 Sharps, because they're coming in as analog signals. We then go, I've got, as I said, the first chip is taken up by running the motors, and then if we actually go back to the software, what I've done then is I've literally done a set of constants, the pins that each of the sonars are on, and you can see how the pins are a bit weird. In some respects they match very well, in other respects, like the Mega, there's bits of gaps in the sides of the pins, but net result being that what we've got then is we're doing as outputs, we're then sitting down and setting all those modes up for us different pins that are on the sensors. We go through, pull in, I'm using a little matrix called bumps, or an array, I still call them matrices, an array called bumps, and 5 I know is the one that's facing forwards. 8 and 2 are the ones that are facing at 66 degrees, 120 degrees each away from the one that's going forwards. So that gives me, so what I've got then is in that matrix, if you consider it, I've actually got in the matrix, so I'm trying to get on the camera, I've got the three things set with 2 gaps in between each one, and in those gaps I then go in sensor by sensor, which what I do is I basically look at sensor 1, and of course it's just repeated. I could potentially do this in a 4next loop, but I thought let's just do them hard, sure. And what I do then, go through and working through sensor by sensor, I'm literally going through all 6 sensors and putting the results into the bumps. And the last thing I'm doing then is just doing a quick serial print just to prove it. And what I'll do is I'll just double check that it's on the right thing now that I've swapped over between the 2. We're on a teens there. Which port are we on? We're on port COM6. Yeah. So let's go in and actually have a look at the serial. Oh, interesting. Why is it saying it's offline? Okay, let's... Right, so between OBS and the serial port, I've just done an hour's worth of running round. At a full start 2 minutes ago, re-recording to discover that I'd lost the Sony camera, which is the one that looks straight down. I've got the second rostrum camera there, which is the close-up one, and the arena cam that's not just at the moment being a wide shot, and then we're back to the actual software. So as I say, it goes through 6 times, and then right at the end is a serial thing, which should be as easy as this to click over and be able to see the serial port running. And if you look at the fourth number across there, if I put my hand in front of the sensor, it drops back up, drops back up. So we know that we're actually, and I'm getting some erroneous values from this line here. It seems to be going, and it could be that because they're all SRF05s. So why that's giving me these, but wherever I put my hand, we're getting changes in the numbers. So the update at this stage is that where we've got to is we're actually in a state now where we're detecting all those sensors. What I need to do now is sit down and decide. I can easily switch the motors on and off. We might do that just before we go. Since we've had very little fun up to this stage, what we'll do is we'll just go into the actual software, and we'll go into, right, I've set my pin modes. So if I go into the loop there and say pick that, there's a digital right there. So if I look at the numbers on here and say I want digital right 5 and 6, let's try actual. See, if you press the function key, the camera swaps. So let's go back and press the actual number. So what we'll do is we'll say, I'm having some keyboard fun at the moment. Right, so we'll copy that command, which will switch 5 and 6 on, and then we'll do a simple delay of 1000. Give it a 1 second delay. Oh, not pressing the shift either, pressing the caps lock. That's good stuff. Got to say this is not my day-to-day keyboard. Oh, 10,000. Let's try 1,000. Yeah, well, it was 1,000 if I had pressed the correct key. You were having a fun day. It'll be interesting to see. Some days life is extremely difficult, and when you're pressing the shift, it doesn't. Oh, well, I've got the caps lock on. That's why. And some days life just seems to be that level more difficult than others. I have a name for days like that. I call them weekdays. So, well, no, you can't do a Control S on this, Garrett. It's not C sharp. We will do a save, and then we'll do an upload, and we should be able to go over to the rostrum camera. We'll go over to the Arduino. It's going to complain that it can't load it. I've got an error at the bottom there that says it says now able to open COM3. Windows said this port was ready before it was actually ready. Okie dokie. Makes you wonder who programs these messages. So, are we still compiling? Yes, we're still compiling. Let's go across to the Sony. Oh, it's actually in a reboot format, it says. Has it? Oh, that's interesting. Ah, yes. We needed a bit more power ego. Ah. Yes, that'll be why. If I can speak over, the reason is I haven't put a delay afterwards. So what's happening is it's switching the motors off and then instantly switching them back on again. So, we'll have to put up with the noise. Ooh, that was interesting. I wonder what happened then. So there's obviously some part of the Teensy programming that tries to talk to Oh, come on, we're still in. Are we compiling? We're still compiling the sketch. We seem to be having a lot of fun. There we go, it's still compiling. There we go. There we go. So, oh, so we now seem to have gone past having to press the button all the time. So that just shows, as I said, more of an update than anything else that I've created this new board. I now need to sit down and think of some clever software to actually be able to, let's just shut that up. I now need to sit down and create some clever software to identify the, now that we've got the ring of sensors working, so this is actually looking at all these sensors and I'm bringing that into an array. We now need to sit down and decide how we're going to deal with that array, and that'll be the sort of first proper tutorial for this new system or this new board. This was more an update just to show you where we're at, and an update with a lot of sweating and swearing. Oh, I didn't swear, did I? Oh, I don't think I did. See you next time.